Hello guys and welcome to this video. This video is trying to introduce you one of the text mining project that I did, and this project is about helping a startup company to find out the best location to start their company. So basically trying to find out some of the key elements, the key factors for a company to consider if they want to start. And here, this video is part one, and I'm going to introduce in this project 4 methodologies for doing this text mining thing. One is to use the TF-IDF model to remove some of the commonly used words shared by a few documents, a group of documents. And then I'm trying to display some of the top frequency terms in each document. And also I wanted to plot a word cloud, especially a comparison word cloud, in order to find out some of the important words that are important in one document but not important in others. So do a comparison across documents. And then lastly, I'm trying to do a topic analysis across these documents trying to identify some of the key topics all these documents reviewed. Okay, so first of all, let me try to explain a little bit about the data that I'm trying to work on. So here I have the 22 text files, and these files are all text files, and they're all about company location selection. They are written by professionals in this industry. And these articles are all very dirty, in a very dirty form. So obviously we need to do some cleaning before we do any analysis. So let's get started to the step one. So step one here, I try to load all these files to a corpus first. So first of all, I need to load it to a file using this list.files function. So basically load all these txt files, and then I store them to a list called files. See here, in the list I get 22 lists in here in this list. And I store all this list to a corpus called docs. So in this docs, this is a corpus, and it has 22 corpus. Okay, just to have a brief review of what document 1 looks like. So basically, yeah. So it now looks like this. So you can see that it is very dirty. So we need to do some cleaning on it. Okay, so and the next steps are is the text cleaning. So the text cleaning is actually very time consuming. It's pretty hard to figure out what's the best way for you to clean your text. It's actually although it has some regular routines for you to follow. For example, just to remove some punctuations, numbers, or like stop words. But depending on what kind of document that you have, what's the features in your document look like. You're gonna have some customized cleaning steps. For example, in here, that you see how we have some of these kind of website address. We need to clean that, and that's a unique cleaning methods. And some of the unique symbols, like see here, this dots. Those kind of words, they cannot be cleaned in a regular way. Sometimes your files is enclosed in a different encoding, so sometimes you have to change your encoding as well. But this is not a major thing that I'm trying to introduce here. So I'm gonna skip this text cleaning part, but I still need to run it. Okay, so I run this my text cleaning part. Actually, I spend a lot of time trying to figure out this way to clean this text. And after I cleaned it, so I still have these docs. I store all of my text files into these docs, and the docs has 22 lists. I just did a cleaning here. And then I convert it to a document term matrix. this document term matrix is pretty important because it actually changes a text to a matrix. So basically, you use a matrix to represent a text. So I'm not going to open it here to try to see what this looks like, but because it's very big, it's very large, and in these R Studio, if it is very easy to collapse while you're opening a relatively big document. But this document term matrix, you're gonna have a pretty sparse matrix with ones and zeros. And in this matrix, so every column, every row, it's a document, represent a document, and every column represent a term. So so if there's a 1 for that cell, that means this in this particular document, it has this particular term. But if it is a 0, that means in that particular document, it doesn't have this particular term. So basically, this is what a document term matrix looks like. Okay, and here comes our major part for today. It's this TF-IDF model to try to remove some of the commonly shared words across this document. So the idea for this model is trying to it just gives more weight to those words that are not commonly shared across the words. So those kind of words actually actually says something unique about this particular document it is in. So actually we need to pay more attention to those words in order to try to find the nuance, across different documents. Okay, so we're trying to use this TDM file that we just have, and we're trying to convert it back to a regular data frame, and I need to use this tidy text package in R. So I do this step, convert and rename, convert row name to text files, and then convert it back to a data frame. Okay, see here now I have this data frame called the docs words. Let's see what does this doc words look like. This doc words just like this. So it has 3 columns: documents, which is the document's name and each term in this document, and the count is the frequency of this term in that particular document. So you see here I have 18 here. So in this column I have 22 documents, and all these terms they just break down to each single term, and I have this frequency. Okay. And with this data frame, I wanted to add some TF-IDF values to it. And in R, it has a function called called bind TF-IDF. Bind the TF-IDF. I need to use that to create these values. So okay, here I run this. Okay, I'm gonna run this. And I see that so this words this doc words turns to something like this. So I actually created the 3 new columns, which is TF-IDF and TF-IDF. We're interested in this TF-IDF column. Let's actually try to print it in here. Doc words. See what does it look like. So for example, this TF-IDF value, if there are zeros, that means that this term is actually pretty common. It's pretty common across all these documents. We actually wanted to get rid of those comments, but rather this is in ascending form. If we want to look at it in a descending form, so by this TF-IDF column. So now you see here, so we can see that this restaurants. It has a comparatively high TF-IDF value. That means this word or this term is rather important for this document, and Latin is rather important for this document 14. So we want to retain them. We actually can plot a graph to see what are those top TF-IDF terms for different across different topics. So I use this code to have a plot. So let's just wait for a second to see this plot. Alright, see here, wow, this is wonderful. Really nice visualization in here. You see that, so for each of these this document, this TF-IDF function helps you to dig out some of the important words in each document that can kind of demonstrates the document's uniqueness, to others. So, for example, this text one, it put more put more weight to engineering or like engineers. And for example, this is text 14. It put more words to Latin America, Brazil, Argentina, or something like that. So we can generally think or came to the conclusion that this document maybe just talks more about those enterprises in South America or something like or some of those kind of regions. And for example, like this here, you see here this 17. You see like labor, China, or Singapore, Indonesia. So it could be like concerned more about Asia, so Asia regions. And this principle goes apply to all of these documents. It goes the same. So it actually shows the idea of how this TF-IDF is helping us to do it. Okay. Okay. So this is TF-IDF, but as I just mentioned, we actually wanted to remove those low value TF-IDF terms in order for us to continue our analysis. So we see that here we want to print this docs out. So you see this kind of terms, or maybe there are more, are the ones that we want to eliminate. So first of all, we want because they share some of the common words or like exactly the same words. We wanted to remove the duplicated the words first, and we're trying to figure out those top 500 words. Well, 500 is just the one that I decided to do that. Well, it actually can be like more, but it actually depends on your decision, your own decision. But I decided to do like 500. So 500 top words. So we can take a look of what those top 500 words are. So yeah, so we got that. Okay, no word. Okay, so see here, these are the words. These are the common word that we wanted to eliminate. So after we do that, we just store them to a list or a value character list called the common word, and we try to remove those common word just as what we did in the text cleaning part. So we remove that in our docs file, and then we convert it back to a DTM again. So now we have a new DTM that has eliminated those top 500 TF-IDF words. Alright, this is it. Thanks for watching, and